The air that infiltrates into and out of a home adds a significant cost to a typical home's heating and cooling bills. In fact, if you add up all the cracks and gaps in a typical home, it's equal to about 2,000 feet. That's equal to about a small window being open all year long. Well, how do you quantify and find out where those leaks are at? Well, you use a blower door. And here to tell us how a blower door works is Scott Johnson from Action Now. Hi, Scott.
How you doing, Steve?
Well, tell me about the blower door and how it works and how you prep to make it work.
A blower door is a simple piece of equipment. It's comprised of a frame and a membrane and a fan and a manometer and a speed control.
Those tubes coming out of the manometer that hooks up into the fan and goes to the outside?
Those are our reference taps to let us know really what's going on with pressures and the airflow itself. When I come out to the house, Steve, I come out to the house and I walk around and familiarize myself with the house, and then I start preparing the house for the test itself. Make sure that all the exterior windows are closed, all the exterior doors are closed, all the interior doors are open because we want to measure up every room, the whole house. And I check plumbing traps to make sure they're full of water. And any fans, any exhaust fans that have dampers, and make sure that they're closed off. Because we want to just go ahead and prep the house for its normal operating conditions.
Okay, so then you turn on the fan, and I guess you could pressurize or depressurize. You like to pressurize homes?
I like to pressurize homes, but depressurize, it just depends on what's going on with the house, Steve.
Yeah, now, so this basically forces air through the house. The manometer helps you quantify that.
Yes, sir.
And what are the typical ranges in leakage that you find on California homes?
Oh, I've got them as low as 400 and up to 9,000 cubic feet per minute, Steve.
Really?
Well, yeah, wide range.
Now, what's typical for a 2,000 square foot house?
Oh, around 1,500 to 2,500 cubic feet per minute.
And we can test this house, right?
Oh, yeah. In fact, let's do that. I'm going to turn on the fans. Here's that membrane I was talking about. This is a manometer. This is a speed tap that we can turn on the RPMs of the fan. We just bring the fan up to a given pressure. As you can see, Steve, we came in at 1,347 cubic feet per minute at 50 pascals.
That's pretty good.
Yeah, it is. It really is. It's below the 3.0 SLA that could have taken credit in Title 24 for this house.
Now, this would also meet the federal Energy Star requirements?
Yes, it would. In fact, it's below that. It's 300 feet below that, actually.
So in summary, basically what this device does, it just pressurizes the house, and you measure the airflow through it, and then you can also go around with a smoke pencil and find out where the leaks are at?
Yeah. In fact, we'll be doing that, Steve. The leakage sites are typically around the windows, around the doors, bottom plates, receptacles. A big one is ceiling lights. Ceiling lights leak a great deal. Dampers, duct systems. A huge one usually is fireplaces. The dampers are either messed up or there's a lot of places around the fireplaces themselves that leak a great deal of air. But with the visible smoke, around this smoke, when the house is pressurized and the air is blowing into it, we can pinpoint exactly where all the leaks are and correct them.
Fascinating. Thank you, Scott.
You're welcome, Steve.